You did your at the EPFL in Lausanne. And yes, you've done a lot of work on recommender systems in the past, as particularly applied to, I think, application areas in mental health. But as we've heard before in the session today, the technological approaches often translate quite interestingly and well to different application areas. So with that said, the stage is yours for the next 10 minutes or so. And we're looking forward to your contribution.
Thank you, Jan, and hello, everyone. Thank you for joining today. I'm excited to take you on a journey through the evolution of recommendation systems and explore their potential as digital companions, especially in the context of digital health. So nowadays, recommendations are everywhere. Whether we realize it or not, they shape so much of what we see and do every day. They actually touch almost every platform we interact with. For example, social media suggests people you may know, YouTube offers recommended videos, while Google adjusts search results based on our prior activity. So, given their pervasiveness and impact, one might ask, is the challenge of personalization already solved? Unfortunately, no. And especially in digital health, personalization is challenging, as the data we rely on is varied and often inconsistent, coming from different sources with different levels of reliability. And health needs are constantly evolving, so recommendation systems must adapt over time. Also, evaluating these recommendations is complex, as health outcomes don't always provide immediate feedback. On the other hand, accuracy isn't always enough because we also have to consider fairness, explainability, and trust to make sure that these systems are meaningful and safe. And finally, keeping users motivated and engaged on the long term is also another hurdle because health improvements required sustained efforts. So, recommendation systems in their first generations were based mainly on two main approaches: collaborative filtering and content based filtering. So, collaborative filtering mainly relies on user similarity. So, if two users like the same items, they're considered similar. The system then recommends items liked by one user to the other. On the other hand, content-based filtering focuses more on the characteristics of the items themselves. So for example, here, if a user likes an item, the system will recommend another item to the user with similar features. In the second generation of recommendation systems, deep learning has become a foundational tool. And unlike earlier methods, which relied primarily on similarities, deep learning allows to capture complex interactions between users, items, and context, which are usually embedded into different vectors and then flow into a network of hidden layers, where deep learning models process these representations to produce a prediction. While these Generation 1 and Generation 2 systems have advanced recommendation technology, their reliance on supervised learning creates inherent limitations, particularly in dynamic fields like digital health. First, they have difficulty with real-time adaptation because supervised learning relies on static training data, meaning that systems can't easily adjust to evolving health needs, new conditions, or dynamic context. Second, these systems tend to focus on short-term outcomes. So, and since supervised learning optimizes for immediate results seen in the training data, it often neglects the long-term health goals critical for meaningful improvement. And finally, there's also issues of bias and fairness, often due to the biases in the training data itself. To overcome these challenges, I think we need to rethink recommendations, not just as suggestions, but as interventions aimed at achieving specific outcomes and having a meaningful impact on users. So, usually the system is faced with a vast array of possible options to recommend. And at each time step, the recommendation system selects an item or more based on the user's context, preferences, or past interactions. And the user is going to engage with this item and provide the response or their feedback to the recommendation system. And this feedback loop enables the system to refine its future recommendations. And over time, this iterative process optimize for desired outcomes, whether this is sustained engagement, adoption of healthier habits, or improved decision making. And this dynamic relationship we saw between the system and the user highlights the importance of designing recommendation systems that are not only accurate, but also adaptive, goal-driven, and capable of optimizing for long-term user values. And this is where approaches like sequence modeling and reinforcement learning play a crucial role. So sequence modeling can help the system understand how users' needs and behaviors evolve over time, while reinforcement learning, on the other hand, enables the system to learn through interaction. So by receiving feedback, whether positive or negative, the system refines its recommendation to align with users' long-term goals and deliver this sustained impact we aim to. And today, with large language models shaping this era, recommendation systems are also evolving to unlock new possibilities for personalization. So LLMs bring several strengths that make them particularly valuable for recommendation systems. So first, they have vast external knowledge. So they are able to understand and incorporate information beyond just the immediate context of the user. Also, they have rich language understanding, which allows them to interpret user inputs, including context, tone, and intent. Third, this interactivity they have can support dynamic and conversational engagement, which is crucial for creating personalized experiences. And finally, they are capable of few-shot tuning, which make them easy to adapt to new tasks with minimal data, making them also highly flexible and efficient. However, despite these strengths, also there are key considerations we need to address when using LLMs in critical domains. First, these models can generate potentially invalid or unexpected recommendations, which could be problematic in sensitive areas. Second, they also have risk of bias because LLMs might unintentionally reflect or even reinforce biases present in their training data. And finally, their limited context understanding means that they can sometimes struggle to interpret complex and evolving health situations effectively. But when we think about the future of LLM-powered recommendations in digital health, there are several exciting opportunities. First of all, we can use LLMs for advanced feature engineering for health data, as they can extract and encode complex information from diverse sources, while also at the same time dealing with missing or malformatted data. Second, we can use these for pipeline control to dynamically manage how recommendations are delivered. LLMs could also improve the perceived usefulness and trust of the system by enabling more conversational and intuitive interactions. Finally, they could also be utilized to translate user context and data into timely recommendations and actions. And I think it's especially exciting here to explore how reinforcement learning and LLMs can interplay together, creating systems that are not only adaptive, but also continuously improving, context-aware, and capable of aligning these short-term actions with long-term user goals. So I'd like to conclude this presentation by also highlighting the opportunities and challenges in recommendation systems for digital health. So the different approaches we discussed can actually be utilized to design impactful systems for various applications, such as, for example, behavior change interventions through, for example, personalized nudges or reminders. Can also support chronic disease management through continuous monitoring and timely recommendations based on wearable and patient-reported data. They can also provide mental health support through real-time coping strategies and mindfulness exercises through conversation and recommenders. They can also support preventative health, analyzing patterns to predict risks and recommend also proactive lifestyle adjustments. But at the same time, this comes with various challenges, some of which relate to privacy and security. Because integrating data from wearables, medical records, and self-reports amplifies the risk of breaches or misuse. Also, healthcare decisions require transparency. So patients and clinicians need to understand how recommendations are generated, yet many of the approaches we discussed act as black boxes, complicating this requirement. Also, as discussed before, many of the discussed approaches are trained on biased or incomplete data. Also, we have to consider how to embed these systems into clinical workflows without actually overburdening users. And as we look ahead, I think that the key lies in balancing innovation with responsibility, designing systems that are not actually only intelligent, but ethical, explainable, and user-centric. And with that, I'd like to thank you, and I look forward to any questions and thoughts.